This lesson will show you how to use properties of exponents to rewrite expressions involving negative exponents in a simpler form. So hopefully you remember what we went over in class. The basic idea is that if you have an expression with a negative exponent, the way you determine its value is by considering what you'd get if the exponent were positive, but making it a fraction. So since 2 to the third power is 8, turns out that 2 to the negative 3 is actually 1 over 8. And that's the basic principle that we're going to use over and over again. It turns out to be quite useful if we have expressions with variables. For example, if you have x to the negative fourth, and you're asked to write that expression without negative exponents, well, what you do is you rewrite it as 1 over x to the fourth, and that's basically the definition of a negative exponent. It could be a little bit trickier if I put a coefficient in there. Suppose you had positive 3x to the power of negative 10. Well, the x to the negative 10, you get to turn it into a positive 10 by putting it in the denominator. The 3 remains in the numerator. As you've already seen in earlier lessons, it's important to be clear about the difference between coefficients and exponents. So for example, the problem I just did, if the coefficient had been negative, well, the negative 3 still stays in the numerator, and then you make it a positive 10 by bringing that to the denominator. Okay, so I'm going to go through some more examples and take notes or remember what I'm doing, because your homework problems will be similar to the examples that I go over in this video. Alright, so let's clear some space and look at progressively more involved expressions. Alright, so the next one I want to consider is quantity 3x squared y to the power of negative 3, all of that raised to the power of negative 4. So what I'm going to do essentially is distribute this outer exponent. So everything inside is going to be raised to the power of negative 4. 3 to the negative 4, x squared to the negative 4, and then y to the negative 3 to the negative 4. And all the rules we've learned about exponents are still true. So since 3 to the fourth is 81, 3 to the negative fourth is 1 over 81. And then we have x, we multiply the 2 times negative 4 and we get negative 8. And then we multiply the negative 3 times the negative 4 and we get positive 12. We can clean this up, put the y to the 12th in the numerator because it's got a positive exponent. The 81 is under the fraction bar, and the x to the 8th, I can make it a positive 8 by moving it to the denominator. Okay, so one of your homework problems will be a lot like that. You can certainly pause the video or watch it again later if you need a reminder of how to do that. Alright, so the next example. Let's try one that has a fraction. So x, y cubed z to the negative 4 over x to the 6th y to the negative 5th z squared. Alright, well, let's think about our x's. There's an x on top and there's 6 x's on the bottom, so it turns out that one of your x's will cancel from the top. So let's do that in a different color. One x cancels, one of these cancels, meaning now you're down to 5. Okay, I like to look at things one variable at a time. So x's from the numerator are gone. In the denominator we have x to the 5th. Now, let's think about the y's. The y cubed, I'm going to leave where it is. The y to the negative 5. It turns out if you have a negative exponent in the denominator, you can make that exponent positive by moving that piece of the expression to the numerator. And then something similar is going to happen with the z's. I'm going to go ahead and leave z squared alone because this is a positive exponent. This negative 4, I am going to deal with that by moving that into the denominator, and now it's a positive 4. Then I can clean that up a little bit. Y cubed times y to the 5th. That's the situation where we add exponents. And then in the denominator, x to the 5th. Again, I can add the exponents on z, and I'd get z to the 6th. Okay. You will have a homework problem a lot like that one as well. I do want to actually show you another way you might approach this problem. So let's undo all the work and just go back to the problem that was given. Alright, now let's just approach it instead as subtracting exponents. So x to the 1st, x to the 6th. 1 minus 6 is negative 5. And then with the y, it's y to the 3rd, y to the negative 5. So 3 minus negative 5, well, that's 3 plus 5, which is 8. And then if you subtract the exponents on z, it's negative 4 minus 2, which is negative 6. And then if you're trying to get rid of negative exponents, you just go ahead and move the parts with negative exponents into the denominator. Okay, so that's just a second way that you could approach that problem if you find that more logical. Okay, now let's look at this will be the last example and the one that's the most involved, and you will have a homework problem like this one as well. So suppose you have a fraction, x cubed, y to the negative 2, z to the negative 5, over x y to the 5th, z squared. And then all of that is raised to the negative 4. Well, as in the previous example, you could do things in a different order. You could simplify inside the parentheses first and then deal with this negative 4 exponent, or you could deal with the negative 4 and then simplify the result. That's what I'm going to go ahead and do. So I'm going to raise everything inside to the power of negative 4. So the x cubed, I multiply 3 times negative 4. The y, I multiply negative 2 times negative 4. And then with the z, I multiply negative 5 times negative 4. And then I need to apply that negative 4 in the denominator as well. So x to the negative 4. Y is going to be to the negative 20, and z to the negative 8. And now I'm going to use the method I used in the previous video, or previous example. I'm just going to subtract negative 12 minus negative 4. You really have to think about your arithmetic with negatives. Negative 12 minus negative 4 becomes negative 12 plus 4. And then for y, 8 minus negative 20 is 8 plus 20, so that becomes positive 28. And then with z, it's 20 minus negative 8. 20 plus 8, that's also 28. And then if you're asked to use no negative exponents, you've got y to the 28th, z to the 28th, and you get your x to the 8th to have a positive exponent by moving it into a denominator. Okay, so that was several examples. When you're working on your homework, if you need a reminder, just go back and look at the problem in the video that was similar to the one you're working on, because each of these is very much like one of the examples that I just went over. All right, have this ready for class next time.